Hey everyone, good morning. Hope you all had a good evening yesterday and glad to see so many shining faces this morning. I wanted to give a little bit of background about why I decided to give this talk. When the opportunity came up to speak, I was kind of thinking about reflecting back on what I've done in my career in data science and lessons learned. And one of the things that occurred to me that I haven't really heard a lot of other people talk about is that I've moved into leading 3 different data science teams over the course of the last several years and converted them from not using agile software development practices into using agile development practices. And there's some ways that that's sticky with getting it to work in data science because it's really meant for software development specifically. And so I wanted to kind of just talk through some of the ways that I've noticed parts were easier to adopt, parts were harder to adopt, and hopefully some of those tips and tricks, lessons learned will be useful to any of you in the future as you continue to level up your teams and become more streamlined and more well-oiled data science machines. So with that, I'll go ahead and get started. One of the things that we're going to kind of talk through today is kind of different types of operational models of data science teams in terms of how the data scientists themselves work. And when I say data scientists, for the record, I don't literally just mean data scientists. I mean the whole function, the whole suite of roles that are involved in enabling a data science team. Data engineers, data analysts, machine learning engineers, all of the folks necessary to carry a data science project through to completion. What kinds of ways those people operate together and some of the sticking points of where they can struggle that then Agile can come in and help us with. And so talk through how that then applies to data science specifically and is different than the software delivery angle. And then again, some lessons learned from the way that I've applied that in various different teams and when it worked and when it didn't and what things to think about as you go. So getting started, let's talk about some different kinds of data science teams. One really common model with data science teams is having, one person dig into, some proof of concept, some proof of value. You have a data scientist latch onto a problem and go really deep in it themselves. They're working as fast as they can or as thorough and rigorously as they can, but they're working mostly kind of as a sole owner of solving a particular problem. And when they work as a sole owner of a problem, that means that in terms of their work output, there's a lot of common things that can happen in terms of they'll work locally on their machine and then that code maybe doesn't get shared back to a team location. They may have a bunch of tribal knowledge that they then build up in their head about how this particular solution works that may or may not get shared back effectively with the rest of the team if that project gets dropped for a quarter or two and then needs to get picked back up later, any things like that. Having things in their own personal spaces versus shared team workspaces, things like that in terms of the code that they write and the results of any analysis or modeling that they do. And so you can have these individuals be really, really high-performing, excellent problem solvers. They can perform stunning feats, but at the end of the day, it makes it hard to sustain the work that they've done. And it's not always just one person. Sometimes it's a combo effort where you have a pair of people or something like that, a small group. But what we're talking about here is kind of small, isolated teams working on solving an individual problem versus kind of the converse of that, which is you have a big project with large scope and everybody on the team or a large fraction of the team is working towards solving this one particular problem. And a very common thing that happens, and especially in situations where teams get some early success from whatever POC they've done, then they scale quickly, right? The business is like, give us more, more, more. We want to build this out as fast as we can. So we're going to bring in a bunch of people. We're going to expand the scope. And then the fastest way the data science team has to go solve that problem is divide and conquer. And so, okay, you get a work stream and you get a work stream and you own this model and you own that model. And everybody does their piece of the process. And you end up being able to deliver and scale up very well and very effectively. But what that brings with it is a lot of handoffs. You have different people who own a different piece of the process, and then that person has to say, okay, my step is done, now it's your turn, you're ready, and okay, your step is done, now it's your turn, and you're ready. And then what if that person is out sick? They end up in the hospital for a week, or they are on vacation going skiing with their family, or whatever it is, and that process needs to run, and that person's not there. Then you end up in situations where there's single points of failure. And it also drives a scenario where there's very few people in the team who have the bird's eye view to be able to provide context for how all these things stitch together. And so it's a really effective means of delivering something, but it's not necessarily an effective means of sustaining it. And so that's another common way that I've seen data science teams work. And then, of course, you can have a combination of those things. You can have teams as an org that you have large projects and small projects. Maybe you have a big group of people working together on one thing, but you've got a few people that are going off and doing their lone wolf approach. Whatever it is, you can have different combinations of these different modes of working. And they have pros and cons, but there's definitely ways in each of them for the sustainability aspect to be harder to pull off. And so one of the things that brings with it is some sustainability issues. And then, of course, there's the larger problems that data science teams everywhere of every kind all have. One of them being data availability and quality. You want to be able to do modeling. You want to be able to get an answer, but you don't have the data for it. You know the data exists, but you can't get at it. Like the example with Graham was talking about where, maybe you have customer transcripts, but you can't use them because there's PII in it. Or whatever it is, there's always data issues of wanting to be able to do more and not being able to get it. Another really common problem with data science teams is the pitfall of becoming an ivory tower, right? Where you have a bunch of really smart people who are dedicated to bringing value and solving a problem, but because they're not close enough to the business or interacting closely enough with various business partners, they may not always be solving the right problem. And this is both a potential pitfall for the data science team as well as the business partners working for them. Sometimes the partners don't know what to ask for, right? They're not asking you for the right question, or sometimes the data scientists don't hear it in the most effective way. And so those are potential pitfalls where oftentimes people struggle to deliver value with data science because they end up solving the wrong problem. Another thing that we've heard several times in the last day is, the importance of sustainability when deploying and maintaining models, being able to look at what happens after the fact, fix things when it breaks. There's always upstream data changes. No matter how good your system is, you're always connected to some other upstream system that can break on you, and you need to be able to remedy and fix that. And again, that's one of those pieces where having that bird's eye context is really important to be able to find and troubleshoot the issue. But if you don't have somebody who knows all of the system, it's then hard to get that. Sorry, I thought I heard echoes. But and then all of this, and one of the things that's very consistent about adoption of data science into any business is the culture change that comes along with it. It's not necessarily what the data scientists are doing or the data science team is doing. It's about getting the business partners around you to change to new ways of working, to prioritize new kinds of things. And that brings us back to where we started, which is that if you can change the culture to prioritize becoming data-driven, then you can invest in things so that there's better, higher quality of data that's available at the points of the process where you need it. And so all of those things are common problems that hopefully feel familiar to those of you who have worked in the data science space. And so that's one of the places where we want to be able to bring in agile practices and see where it can help us with these very common problems. So the key pillars of agile are these four things here. And so really what we're focusing on is individuals and interactions over processes and tools. You want something that's a working product, not just documentation, which is a really common issue in data science stuff. You want to deliver something that actually can get used. That's not just cool and interesting, but can actually get used, right? You want to have a collaborative environment with your customers, whether that's external customers or internal business stakeholders, over negotiating exactly what the requirements of the situation are, and then being able to be iterative and respond to change instead of just making this high-level plan and waterfalling it all the way through to the end and following to whatever the design of the solution was 10 months ago when you started this project. You want to be able to change with what you learn over the time. And hopefully that feels familiar because science is all about iteration. You should be learning as you go. If you're not learning as you go, you're not actually doing data science, I would argue. And so what this gives us then is an opportunity to have a cycle where we're by design, iterating. And so you have planning at the beginning, obviously. You have to start with a plan. But as you design and develop and test, you learn new things. You go ahead and use what you've learned in some ways to deploy something, give your stakeholders something. And we'll talk about what that looks like because, again, this is a place that it differs from traditional software development. In traditional agile development, that means some working code that does a thing. Data scientists don't always deliver that. That's not necessarily the output. So it depends on the part of the life cycle that you're in, and we'll talk about that in a second. But the other really important thing, and this has been fascinating to see because data scientists love learning things and thinking deeply about problems, but the number of teams that I've been a part of where we've made things and then didn't have the time or process to step back and figure out if it was good or working or keep track of how it was doing is surprising. And so I think that built-in review cycle of how do we work better, how do we get our model to work better, all of that stuff is really critical and is a thing that seems obvious, again, for a data science team, but doesn't always come through in practice because you have lots of requirements coming in, lots of asks from stakeholders, and you're trying to move as fast as you can. And so it's important to build it into the way that you work so that it's not a nice to have, it's a must have. And then again, you do it all over again. Every time you learn something new, you make new pieces of your process. So hopefully you can see how this approach to working and having that kind of an iterative process is going to help us with some of the problems that we identified earlier that teams struggle with. So what does Agile look like day to day? Probably many of you know this, but I'm going to walk through it in a little bit of detail because I want to pick apart, again, the actual adoption path later. So we're going to walk through kind of some specifics on exactly what does it look like day to day. Not just the culture change that happens with an Agile mindset, but like how do you actually make your team function differently? Working based on sprints, right? Not just an infinite cycle of constant intake, but like having specific deliverables in bite-sized chunks, usually 2 weeks, but not necessarily. It can be a month, it can be a week, however long you want it to be. But having a planning session at the beginning of like, this is what I'm setting out to accomplish, and then having time to work on it where you design, develop, test. All through that process, you're doing daily stand-ups. Again, this is a thing where depending on the way that the team works and what kinds of problem you're solving, the different data scientists trying to solve different parts of the problem may not be talking to each other on the daily about like which things they're trying to figure out and stuff. And so it's really helpful to have those stand-ups to be able to communicate and provide visibility. And then at the end of your sprint, having 2 pieces, something delivered, whatever it is, we'll decide and talk about that in a second, to share with stakeholders. Getting that in actual opportunity to get the data science team in the room with the stakeholders and get feedback on what they're doing is super critical. And then also taking a separate piece of time internal to the team to sit and have a retrospective and figure out what was working, what didn't, how can we do better, right? And so that's in a large scope how operationally day-to-day data science or agile processes work. And you can see that when you have this sprint-based cycle, you have the opportunity then, there's built-in opportunities for both doing the work, planning the work, reviewing the work, and doing it all over again and being able to build higher and higher and better and better. But one of the things that we need to take into account, again, is that data science isn't software development. It's different. It works differently. And so this is kind of an overview of the life cycle of a data science product, which is that at the beginning of the day, when you have some idea, you have to figure out if you even have data to be able to solve that idea. Maybe data exists, but you don't have access to it. Maybe you need to get access to it. That might take you weeks to months, depending on what company you're at and what your infrastructure looks like. Maybe it turns out that you do get access to it, but it doesn't really solve your problem because it's got a bunch of missing data, or it's not of a quality that you would be able to use, or whatever it is, right? There's lots of pieces just about the data that has takes a lot of time at the early part of any kind of project. And then even once you have the data and you're roughly sure that it's going to be useful, you have to actually do some sort of proof of concept feasibility study to actually build a model on it and see if you're going to get out something that will be usable by the business. Just because you can build a model doesn't mean that it's going to give you enough ROI to make it worth going through all of the rest of the process. And so you need to take the time to figure out how feasible it is to actually use what you have. And then once you've gotten to a threshold where you've decided, okay, green light, go ahead, I'm going to go and I'm going to put this thing out into the world, you can do further model optimization, further hyperparameter tuning, bringing in additional data sets and features. You can do lots of parts of the model development optimization, as well as the productionalization part where you bring in your machine learning engineers and make sure that that model is built in a way that it can actually be put into production. And so whatever you need to do in terms of testing and robustness and all of those sorts of things, you have the opportunity to do that once you actually kind of know what model you're working with and what framework you're going to end up with at the end of the day. And then, of course, once you've built something, you put it out into the world, you need to have that monitoring and governance to be able to continue to iterate and learn from it and see how it's doing. And so one of the interesting things, this again should be very familiar to all of you who have done any kind of data science work. This is kind of just a generic summary of the way that the data science lifecycle works. But there's an important distinction here. And it took me a long time to kind of realize and break it out this way. Steps 1 and 2 here are the ones where there's the inherent uncertainty. Whether you can get good data and whether it's going to be useful for solving the problem and whether there's a modeling solution that's actually going to drive the ROI that it makes it all the rest of this worth it is the part that makes it data science. That's the piece where the exploratory stuff comes in and the discovery and the science and the iteration piece. And so what you deliver in terms of Agile best practices is different if you're in the early part of this cycle or if you're at the later part. Once you're into phases 3, 4, and 5, you kind of can treat it like software development. Like you know what model you're going to use already. You might try some other ones, but you know what deliverable you're going to have. You know what system is going to need to integrate into. You know what tests you're going to need to build. Like a lot of that stuff is figured out at that point. And so when you get to step 3, then you can start to just treat sprints like regular software development sprints, do tickets the way that Agile teams and software development do tickets, and all of that makes a lot more sense. So really, as I get into the later part of the talk, I'm going to spend a lot of time talking about how phases 1 and 2 differ from the software development side, because that's really the piece that sticks out and is different for data science teams. And so that's the point of the kind of looking at it and breaking it apart this way is at different stages of the process, what you deliver as your working product is a different thing. And so thinking about it that way and making Agile work for you, knowing that there's those differences, is really the key thing that enables teams to be successful using this. So then let's talk through what some of those tips and tricks are. And just, I want to kind of walk through from, I know it's about people and interactions, but really we're going to talk about process here for a minute. The places where I've seen it easiest to bring Agile practices into data science teams and kind of the order of adoptions. So first thing is start doing stand-ups and writing shit down in tickets. Like it's important to have people write things down, and data scientists don't always do that. And so writing it down in a place where other people can find it and having visibility to other people of what you were thinking so that, again, 6 months from now, 12 months from now, when somebody asks that same question again, you can be like, oh, I remember we looked into this. I didn't work on it, but I know so-and-so did. I can go back into our collective documentation and figure out what was going on. And it doesn't need to be like massive, perfect documentation the way that people think of at the end of a project where you're like writing up all of the things that a person could possibly need to know about this. It's just kind of sharing bits as you go so that you have the opportunity to capture bite-sized pieces of information, and it's a lower threshold to entry to get you a built-up documentation base that captures that tribal knowledge out of people's brains. And so then doing the stand-ups, the other thing I have definitely gotten many, many teams to give me feedback on this is just the benefit they get from knowing what other people are working on and being like, oh, that's a cool idea. I didn't even think about that. We should talk about this. You know, like the ability to do that collective brain share is really valuable for data scientists, and most times they love doing it, but there's not necessarily, if you don't have a forum where that's a built-in thing for you to do, it may not always occur to people. And so building in part of your just working dynamic day-to-day to provide that opportunity is really, really valuable. Again, this makes people know what things are going on because you've written it down. People were aware of it as it was happening, so you avoid potential for rework. And then also, because you're providing visibility, there's no more single points of failure because everybody knows everything that's going on. And so then you don't have that one person who has to be the person who runs that particular code and queries that particular table because they're the only one who understands how that works. The other thing that's a difference between kind of more software development and data science, especially again in that early uncertain part of the process, is what do you write down as a ticket? Like when you're a data scientist, you're like, I don't know, I'm like exploring a data set. That, for the record, is a bad ticket. That's way too ambiguous and like high level and can go on infinitely, right? Like what you want is a goal so that at the end of the sprint you can say, did I do this thing or not, right? So I'm gonna look into this data set to see if columns 4, 5, and 6 look valuable for using in my model. And I'm gonna test these 3 things about those columns to see if that's actually gonna pan out and be useful for us. Or I'm going to make sure that everybody on the team can get access to this data set. Or I'm going to try, building, in the modeling stage, right? It's not just like, oh, well, I'm going to model until I get something. Which again, if you're not working in this kind of a framework, is very easy to slip into as a data scientist. It's, oh, well, I could try that, or I could try that, or I could try that, right? Like you have so many potential options. So just jotting down, like I know I want to try these 3 different kinds of models, and I know I'm probably going to want to tune some of the features in these ways. So I'm going to go ahead and just jot that down, and at the end of the sprint, I'll know whether I did that or not, right? Like you have a binary yes or no, did this thing happen? So that's a really important piece. The other thing that's really important, though, is that sometimes, especially early in a project, you don't know what all those questions you're going to ask are. So one of the things that I've found to be very valuable in terms of making tickets, again, in early stages of a new work stream is, apologies, actually making a planning ticket where the ticket and the objective and whatever time it is you say you're going to take to complete it is to figure out which things you want to test and what parts of the data you want to look at. And you may not know all that up front. You can make a ticket for one day to spend a day doing the planning to figure out what the tickets for the rest of the sprint are going to be, right? And so you don't have to have all of that figured out up front. In fact, it's actually really, really important to bake in time to do that and consider that that is part of the work. That's actually a really big, important part of the work. One of the things that's really cool that just naturally flows out of this after, regardless of if you've done any kind of culture change with your organization or any of that, is now you have a list of things written down. You have a list of ideas. People have been keeping track of other things that have been going on the team. They also have ideas. Those get written down. Now all of a sudden you have a backlog and you don't just have a team of people who are like, but I could try everything, It's one of those where you have the opportunity to actually say, no, like we have a really good list of things that we know we want to try. We haven't had time to get to them yet. And that gives you the opportunity to prioritize, which is really, really valuable because when you have that written down and prioritized, then going back into conversations with your stakeholders, you have ammunition to arm you against firefighting. Because if they bring up, oh, well, I really need you to look at this. Oh, there's this thing that just came up. You can say, okay, well, these are the next 5 things I'm working on. Is that more important than the next 5 things I'm working on? Even if you don't have it in some kind of like roadmap that you've shared with anybody or anything like that, just being able to articulate, like, this is the cost trade-off of me jumping in to solve your problem versus what my team could actually be doing and what we have planned out to be doing. Sometimes the firefighting needs to happen. And it's something that needs to be dealt with and you need to have the team jump in. But having a mindful trade-off conversation where you're saying, like, look, this is what's going to be impacted by jumping in on this urgent request makes you be able to have more informed conversations, which actually makes those trade-off requests less contentious, I've found. Because then you're not talking about like, well, why you manager just don't like me and aren't prioritizing my stuff. It's like, no, you're not prioritizing my stuff because I've showed you I'm actually prioritizing these 3 other things that actually do impact more than what you've asked for. So it gives you a lot of data to come into those conversations so that it's less contentious. And then the other thing that it gives you is the opportunity for less wandering on the part of the data scientists. There's lots of cool things people can do. There's lots of fun stuff to discover in the data. There's always a point at which you are past the point of making meaningful incremental gains, right? You always get to the point where you're starting to just rabbit hole for the sake of rabbit holing. And that is a thing that this visibility and prioritization allows you to have an opportunity to avoid. Not that data scientists shouldn't have opportunity to do that, but again, bake it into your planning, make it be intentional, don't let it be something that just drags on forever because that's what somebody just is spun up about and continues to work on because that's what they feel like doing. So we've talked a lot now about just basically the value of writing down tickets and talking to each other every day. That's pretty much everything that all the value we've gotten so far is from that. Again, now that you have this prioritization ability, you can plan. Once you have a plan, you can have intake. That changes the dynamic of how you work with your stakeholders. That's where you start to enable culture change, not just within the team, but in the intersection of the team with other teams. Because that means that then you can have the opportunity to insert an intake process. I've been on so many teams where everybody agreed there's a plan, everybody agrees there's a prioritization, but this one person's been working on something for a really long time and this other manager knows that person because they've worked together for 2 years, and so they circumvent any intake and planning process and just email that person on the side or message them on the side and we're like, hey, I just need to know the answer to this question, like, can you just get this thing for me? And you have so many routes to where requests can come from that you're doing unseen work a lot of the time. And then your data scientists get strapped for bandwidth and they're like, well, I can't do all these things, there's too much stuff going on. And you're like, no, there's not. Like, we have a reasonable plan here. There's not that many things going on. And they're like, no, but it's because these 4 other people asked me for stuff. And I'm like, well, if that's not written down, how was I supposed to know it? Like, how do you see that work? Part of the point of this is seeing all the work and counting all the work so that you have realistic bandwidth estimates for what people can do. And then again, once you've done the trouble to write this stuff down and you have a prioritization and you've gotten alignment with your stakeholders on how to put requests in for intake, now you have a roadmap. Now you have the ability to not just be like, oh, I'm a data science team and I guess I'll figure it out. Okay, we have this problem, come back to me in 6 months, I'll let you know. Now it's like, okay, 2 months out we'll give you this, 4 months out we'll give you this, 6 months out we'll give you this, and we'll revise as we go, but right now, based on what we know, this is our plan, right? And you have the ability to, again, one of the things of interacting with stakeholders, and data science has come a long way in the last 5 or 10 years, but really there's still enough people who are hesitant or nervous about adoption of data science and how they integrate it into what they do. The more you can provide visibility and share that you have a plan, the more it eases that uncertainty and helps people work together with you collaboratively, which again is one of those agile principles. Another cool thing that you get, again, just out of writing stuff down and talking every day, is those tickets become data for you. You have there's tons of ticketing systems. You can use Trello or Jira or GitHub or GitLab or whatever it is that you want to use. But once you have that stuff written down, you can tag it. And if you tag it, you get data. And then you can start to do lots of cool things about how to make your team work better. One of the things that's been really fun for me, actually, this was a team member of mine who took it upon herself to go through all her tickets and figure out how she's been spending her time over the last year, to figure out if there's directions, if she needs help on her project, that's something different. She's spending a ton of time building a data pipeline. She's a data scientist. She needs a data engineer to help her, right? Now I know that because I know how she's spending her time. Or I know I need to go to my boss and be like, hey, I need headcount. I need a data engineer because look at all this time my data scientists are spending on building data pipelines. That's not what they're good at, honestly. That's not where they could be delivering the most value. Let's get somebody in to help them, right? And so it gives you a lot of database-backed opportunities to have different kinds of management conversations. The other thing that I've seen be really super valuable about this is, again, a lot of time data scientists, myself included, have when you're in that discovery mode, it's very hard to estimate how long things are going to take. And let's be honest, most people aren't good at it anyway. They don't estimate times very well. I don't, certainly. And so once you have these kinds of things written down and you know what type of work was happening on each ticket, you can actually look at that as data and say like, well, how long did it take to do it? Okay, I know that over the course of the last 6 months, we've done this many exploratory data analysis projects, and this is how long they tended to take. So then now I have better estimates for how I spend my time on the next sprint, have a better plan, have a better roadmap, better conversations with my stakeholders, and interactions with my customers. Now, one thing I will say, though, doesn't work well, and again, this is one of those parts from the first 2 phases where there's lots of uncertainty in the data science piece of the life cycle. You can't really do burn down charts the way that a lot of agile software development teams do, because again, they have much more fixed requirements and have a lot better estimates in general of how long things will take. And so whether or not you're going to actually do absolutely everything you thought you were going to do at the beginning of the sprint is pretty unlikely, because you know things are going to change along the way. And so being able to capture that change and have reasonable expectations is one of the kind of modifications you need to be able to use this effectively in data science settings. Again, though, going to the trouble to have a plan and communicate really effectively often with your stakeholders, and maybe what you communicate is, we spent 2 weeks looking at the data and we evaluated this, this, and this, and here's what we found. This data is or is not going to be useful to us, or we need more time because what we found is something that we think is promising. Do you, stakeholder who know the business more than me, also agree that it's promising? Oh, you do? We'll prioritize that for what we're going to work on next time, even though it's not what we thought we were going to spend our time on, because we're all in agreement that it's worth it for us to spend some more time exploring here rather than just pushing forward with the plan that we already had. And so then you're bringing them along with you, which actually helps build up the data science adoption in the first place and prove to them that you're not just going off in an ivory tower and you'll come out months later and something will magically be the outcome of your data science team. It really also helps facilitate that data science isn't magic. You're giving the opportunity to educate your partners as you go. And so, again, that building trust and having reasonable expectations and setting those reasonable expectations in really regular conversations with stakeholders is really, really valuable. So then, again, taking the time as a team to do retrospectives. This is one of the things that it's stark when I think about it, because data scientists love to figure out how to make things more efficient, love to solve problems, but actually taking time as a team to step back and be like, hey, how did it go? What can we do better? What do I want to try? Is a really interesting culture change that not a lot of teams just natively think to do. And so, or they do it so informally that it's not captured in a way that you can systematically act on it. One interesting thing that I've seen happen in this situation, though, is when you start doing retrospectives, in particular in teams where you have lots of people working on diverse projects, is that there's not a lot of ideas early on, because a lot of people don't have enough context for the things that are going on to have those ideas yet. So sometimes as you start this retrospective process, it can be kind of quiet, and that's okay, and that's normal. One of the other problems I've also seen with data science teams is they give you too many ideas. It's like, okay, now we understand, we have this context for how all this stuff works. There's so many things broken. Oh my gosh, we could make this more efficient. We could deliver this thing. There's so many opportunities. And sometimes it's scratching an itch for them that doesn't actually provide business value. And sometimes it provides value, but it's like, okay, they spend 5 minutes running some code instead of 2 hours running some code, but they only do that like once every 6 months. So like, really, is it worth it for them to spend a couple of sprints to do that work? Like, you can have meaningful trade-off conversations then. But again, in terms of even the data scientists and the way they spend their time day to day, you can have too many ideas, but then once you do that realistic prioritization and ranking, it gives you the opportunity for people to understand why there's this thing and it's been bugging me and it's been bugging me and it's been sitting there for 6 months, and you know why you're still not working on it, right? It's a decision that we all made together, and so it makes it sometimes a little bit easier to set on a shelf and move forward with other things. One other quick tidbit I wanted to share, because I've never seen anybody really do this before. In my new team that I've been in for the last year or so, we started doing Agile for the enablement of the team. So all of the different projects have like a super to stand up, and what we do is we talk about like what management things need to happen, not what work needs to get delivered by the data scientists. So this is, hey, What upcoming presentations are happening this week? How many external facing stakeholders are we talking to? Do we need to prepare content? Do we need to figure out if we need to put new analysis tickets on the actual regular stand-up board to make sure that we have data to be able to put in that content, right? So it enables kind of the planning at a little bit of a higher level in terms of engagement with other teams and other stakeholders. Or where are there help or decisions needed? This has been really valuable for me because when you're in a situation where you have lots of projects going on, airing out what decisions are getting made by the leads who have the autonomy to run those things, but showcasing and airing out every day which things are getting decided, why did we decide that, what was the risk associated with it, has been super, super valuable. And then we also sometimes, our team has a cyclical planning process, and so when we're in that planning cycle, we have monitoring tickets where we just say like, okay, this week, like these were the deliverables, this is gonna go Thursday, this is gonna go Friday, are we good, are we not good, are we stuck, is our infrastructure working, all of that stuff. Gives us the opportunity to just every day check in and air that out. And in particular, the infrastructure thing has been super valuable to go back and talk with other teams about and be like, here's the list of all of the times this was down or broke or not available while my team was in this planning cycle. Let's work next time to make that work more fluidly. With that, this is my last slide. So we're all working together, pulling in the same direction. And when we have more visibility and more ability to plan, it's actually better to bring the team along, and it's easier to bring your stakeholders along with you. And so with that, I will wrap it up. And I know we're about at time, so I don't know if we have time for questions. Yeah. Awesome. Thanks.
Thanks a lot. So regarding your ticketing system, as a lead, like what type of attributes is a must, and how do you diagnose your team's performance? Like what's a red flag for you as a lead, when you monitor that ticket?
Yeah, so the first piece is what kind of metadata basically do we collect. One of the things that I've found really valuable is type of work. Again, is it data engineering work? Is it analysis work? Is it model building? Is it software, testing and doing deployment stuff, just to be able to get at resourcing needs, collaboration needs, things like that. Where are we really spending the bulk of our time? And then the other thing that I've found really valuable to capture is who the request came from, or what stakeholder group is going to benefit from it. Because one of the things that I am experiencing a lot in my current role is, sometimes you have squeaky wheels. And then you have other groups of people who are not as squeaky, but they actually have a lot more impact. And so being able to keep track of how much time am I spending responding to one group over another group has been super helpful in terms of that tagging piece. And then how do I decide if the team is successful? They're largely self-governing on that. So it's basically, they set out, air out a plan, put together their tickets themselves, air that out and stand up, and then they keep each other accountable for whether they're delivering on that. So, yeah. Cool.
Awesome. Really great presentation.
Thank you.
I really appreciate it. So I was wondering, how did your team member actually take tickets and calculate the percentage of time that she was spending in all of the aspects?
Yeah. So we use GitHub for our ticketing, and it has an API that you can just pull down all of the tickets, and it has all of the metadata associated with them. And so then she just pulled it into a table and did a count by tag, and then was able to see how much she was spending her time on things.
I know with Jira, it's I don't remember what it's called right now.
The story points?
Exactly.
Yeah.
And so that becomes a little complex because everybody sees story points differently. But does the GitHub system actually give amounts of time? Or
so no, GitHub specifically doesn't. A lot of the other ones do have ability to capture either dates or points or however you want to do that. I've actually tried it a few different ways with teams where we're just consistent about we'll put in brackets at the beginning of the ticket. This one's going to be 1 day. This one's going to be 3 days or whatever. And then you can strip that out when you pull it down just using text processing. Or one of the other things we've tried to do is, as long as everybody's doing it the same, you can do it, right? It's just when people on the team aren't consistent about the way that they make it, then you get into issues. But if everyone decides a ticket is a day's worth of work, whatever that is, then you have a unit to be able to just sum up and count to, right? And so those are a couple of different approaches I've seen that I've used. Again, I don't think one is particularly better than the other or anything. It's just being consistent because you need, when you pull them down, to be able to compare against them. Yeah. So,
thank you.
and I've actually, our team pulls this down from the API. We have a dashboard, so we see how many people were working on which tasks and milestones and stuff, and how long it's taken them to complete. And we actually use that for our inner team operations and management. Yep.
Thank you so much.
Yep.
Can I? Okay. So.
Where are we? Oh, there you are. Yeah, sorry.
So I love this idea of using the tickets as data to plan the work, but how do you convince the teams? Kind of what she was asking. How do you convince the tagging to be thorough and consistent? Like that sounds like a...
Yeah, well, and that's one of the things that you get value in doing daily stand-ups because you see it every single day. And so it's like, oh crap, we forgot to label that one. Now we have the opportunity to do it. You know, whoever it is that's running your stand-ups, you kind of want them to be the guardian of best practices and point out, like, you don't want that person to have it on the hook to be the person who has to write all the stuff down for people, right? People can write their own stuff down. They can tag their own tickets. They're all adults, like they can do that. But having the opportunity to reinforce and remind them in stand-ups and then just make it a team culture and a team norm is really the way that we've approached that. And you're right, sometimes it's not 100% adoption, but like you can get pretty good results by just, again, if you're reinforcing it every day, people have the opportunity to do it on the fly while they're in stand-up, and so then it's not a problem. So, yeah, awesome. Well, thank you, everyone. It's been great talking with you.